it's not. Hello? Hello, hello. Hello, hello. Hello, hello. Okay. Hello, hello. Yeah. Hello, 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 hello. Hello, hello, hello. Hello, hello, hello. Hello, hello. Okay. All right. Well, I apologize. I think the first 14 minutes are no sound, and I don't know what to say about that, except I'm sorry. Um, Formatted IO. Okay, so what I wanted to try here, I wanted to see if I get rid of this, and I get rid of this, this, and then I put this within a print F statement. Char inputted. So char inputted was, and then we'll do percent D, and then put char. Will that essentially give me the same results as if I had done it the other way? So let's see here. Let's see, Charmander. Let's see, we'll do W. Char inputted was 119. Uh-huh. So, oh, char is probably a, let's see, C. Now will it be a char? I'm thinking it probably will be. Let's do R. There we go. Char inputted was R. All right, and then I need to add a new line to that. Yep. Okay. Compile. Then we'll do that. So we'll say T. There we go. Char inputted was T. Very cool. Okay. Formatted IO. Reading and writing data one character at a time can be painful. The C standard IO library provides several convenient routines for reading and writing formatted data. The most commonly used one is printf. Right, that's what's right here, printf. We've actually used printf a lot. The most commonly used one is printf, which takes as arguments a format string followed by 0 or more values that are filled into the format string according to patterns appearing in it. Here are some typical printf statements. Printf hello, print hello, new line, printf %c equivalent to put char. Ah, see, that's what I was saying. Yep, okay. Printf %d, print an int formatted in decimal. Printf %u, print in an unsigned int formatted in decimal. Printf %o, print in an unsigned int formatted in octal. Ah, okay. Printf %x, print in an unsigned int formatted in hexadecimal. Interesting. So F, okay. Print sent F prints X a float or double. Okay. For a full list of formatting codes, see table B1 in Kernighan and Ritchie or run man print F. Yeah. Man, is it the third section? Yeah. But I think we can do print F and then the section, right? Because it doesn't matter. Yeah. Okay. Format. Yep, there's the format controls. Nice. Is that the full list though? That is okay. Man 3 printf. Ah, yeah. That's way more information. Okay, so you have to put the section early on. Okay, so what about you have to put the section. Okay. Info 3 printf. Does it do the same thing? Info printf 3. That's MD5. What? Okay. All right. For a full list of format, the inverse of printf is scanf. The scanf function reads formatted data from standard in according to the format string passed in as first argument and stuffs the result into variables whose address are given by the later arguments. This requires prefixing each argument with the AND operator, which takes the address of a variable. Format strings for scanf are close enough to format strings for printf that you can usually copy them over directly. However, because scanf arguments don't go through argument promotion, where all small integer types are converted to int and floats are converted to double, you have to be much more careful about specifying the type of the argument correctly. For example, while printf %f x will work whether x is a float or a double, scanf %f and x will work only if x is a float, which means that scanf %1f and x is needed if x is in fact a double. Okay, LF. Okay, some examples. Scanf %c and c, like c equals get char, c must be a char, will not put end of file in c. Oh, okay. Scanf %d and n, read an int formatted in decimal. Scanfu, read an unsigned int, so on and so forth. Read total, an int, and average float on 2 lines with labels. Will also work if input is missing new lines or uses other white space. See below. Scanf total %d, average %f, and total and average. Okay, so total is an int and average is the float. For a full list of formatting codes, run man 3 scanf. Yeah, the scanf routine usually eats white space, spaces, tabs, new line in its input whenever it sees a conversion specification or a white space character in its format string. The one exception is that a %c conversion specifier will not eat white space and will instead return the next character whether it is white space or not. Non-white space characters that are not part of conversion specifications must match exactly. To detect if scanf parsed everything successfully, look at its return value. It returns the number of values it filled in, or end of file if it hits end of file before filling in any values. To detect if scanf parsed everything, look at its return value. Okay. The printf and scanf routines are wrappers for fprintf and fscanf, which take a stream as their first argument. Fprintf, standard error, building on fire, %d, %, burnt, %. This sends the output to standard error output handle, standard error. Note the use of %% to print a single percentage symbol in the output. Rolling your own I/O routines. Since we can write our own functions in C, if we don't like what the standard routines do, we can build our own on top of them. For example, here's a function that reads in integer values without leading minus signs and returns the result. It uses peak char routine we defined above, as well as isDigit routine declared in C type. Peak char? Yeah. Return the next character from standard int without consuming it. Int peak char, int C, C equals get char. If C is not equal to end of file, unget C, standard in, put return C. Read an integer written in decimal notation from standard in until the first non-digit and return it. Return 0 if there are no digits. Int read number. Int accumulator, the number so far. Int C, next character, accumulator equals 0. While C equals peak char is not equal to end of file and is digit C. C equals get char. Accumulator, shift previous digits over. Accumulator multiply equals 10. Accumulator plus equals C minus 0. Add decimal value of new digit. Return accumulator. Here's another implementation that does almost the same thing. Int read number to void. Int n if scan f %u and n equals 1. Return n, else return 2. The difference is that read number 2 will consume any white space before the first digit, which may or may not be what we want. Very interesting. Int accumulator, the number so far, next character, accumulator. Get char. Read an integer value in decimal notation from standard input until the first non-digit and return it. Return 0 if there are no digits. Int accumulator, the number so far, next character, accumulator equals 0, while C equals put char is not equal to end of file and is digit. Okay, so if I put a 1, now, okay. Accumulator plus equals C, add decimal values, new digit, 1, C minus. Here's another implementation that does the same thing. The difference is that read number consume any white space for the first. May not be what we want. Recursive descent parsing. More complex routines can be used to parse more complex input. For example, here's a routine that uses read number to parse simple arithmetic expressions where each expression is either a number or of the form expression plus expression or expression times expression. The return value is the value of the expression after adding together and multiplying all of its sub-expressions. A complete program including this routine and the others defined earlier that it uses can be found in examples io calc.c. Define expression error. Read an expression from standard in and return its value. Returns expression error on error. Int read expression void. Value of first, value of second, operation. Okay, so this is recursive. This is a recursive function. So C equals peak char. If C is equal to that, C equals read expression get char. If, okay, here's the base case. If C is not equal to return expression error, else switch op case return E1 times E2. Because this routine calls itself recursively as it works its way down through the input, it's an example of a recursive descent parser. Parsers for more complicated languages like C are usually not written by hand like this, but are instead constructed mechanically using a parse generator. Don't know what that means, but we're going to add it to our notes to figure out what it means later on. Yeah. Programming. Reference. Okay. What are these things? Descent and a parser generator. Okay. File I/O. Reading and writing files is done by creating new streams attached to the files. The function that does this is fopen. It takes two arguments, a file name and a flag that controls whether the file is open for reading and writing. The return value of fopen has type file pointer and can be used in putc, getchar, fprintf, etc., just like standard in, standard out, standard error. When you are done using a stream, you should close it using fclose. Here's a program that reads a list of numbers from a file whose name is given as argv and prints their sum. argv and prints their sum. Okay, includes standard out, standard sum integers in a file, includes bug fixes, contribute. Int main, int argc, file pointer. Standard C that prints a message about the last failed library routine prepended by its argument. Oh, p error, argv exit 2. Exit returning 2. Else everything is okay. Sum while scan is equal to 1. Sum plus print not strictly necessary, but it's polite. Fclose returns 0. To write to a file, open it with fopen file. Note that as soon as you call fopen with the W flag, any previous of the contents of the file are erased. If you want to append to the end of an existing file, use A instead. You can also add plus onto the flag if you want to read and write the same file. This will probably involve using fseek. So that's literally the same as, so like if I did, so say we're in chapter 10 and I do like test.py. This is literally like I can do with open, we'll say test.text w as f.write. This is my text. So I'm just saying this is literally like the way you do this in Python. So then if I like save this and we compile this, well, we don't gotta compile. We can just go to here and then I can go ls and I can do Python test.py test.py Python 3 test.py module error. Why isn't it? Do I just type in the Python then? Python test.py Python 3 test.py. Oh man. Okay, and then we can look at less test.text. Right, and it's going to be this is my text. So it's like literally the same API per se. I mean, but Python was what's the word I'm looking for? Python was let's just look it up in Wikipedia. Python was influenced by C, right? Yeah. Oh, yeah, it's kind of based on C. This is exactly the C API. What do you mean it's not based on C? This is exactly the C API, right? Like literally, F open is the same, you know, it's the even the same flags. If you want to read and write the same file, this will probably involve using fseek. Some operating systems make a distinction between text and binary files. For text files, use the same arguments above, with the binary flag adding a B to write a binary file. Leave a greeting in the current directory. So, you know, similar, yeah. Yeah, unlike puts, fputs doesn't add a new line. F equals open, fputs. So if I'm looking at this fputs, I'm assuming, oh man, fputs 3. That, yeah, fputs is the file stream. So that's the file that we just opened, and it returns an int. Then put C is the same. It takes in a file stream. So these are kind of the low level. But then if we look at, so let's just open Python 3. Let's do help. Let's just do with open. We'll do test.text again, and we'll do that we want to pen to this, right? We'll pen to it, and then we'll do as f, and then we can do print, and then we'll do help f dot write, right? Okay. Oh man. Okay. Print help f dot write, and then we'll do f dot write, and we'll say second line. Well, let's do a new character, and then say second line here, right? And then boom, boom, boom. Why? Invalid syntax. Let's just do, we can close it afterwards. So I'm gonna just do f equals open test.text. What I'm trying to prove is that it is really okay. And then we have f, we'll do help f dot write, right? Okay, returns the number of characters written, which is always equal to the length of the string. Writes string to string. Method of IO text.wrapper. Okay, so based on that, let's kind of screenshot what that says there, right? Or actually, we can just copy it, right? We can just copy it, and then we'll open Scratch here, Scratch, and then let's just paste it, right? Okay, and then if we go back here and we do exit, and then we do man puts f puts, right? F puts. Is that what it is? Yeah. F puts 3. There writes the string s to string without terminating its null byte, and it returns an integer. So it's exactly the C API. So that's really kind of cool. That's really kind of cool. All right, I'm gonna leave it at that for today. So we just did a little bit more. We kind of just went over some overview and then finished up the chapter 11. We'll pick up with chapter 12, statements and control structures, on the next stream. What I did want to show you before we leave is that if you go and look at the previous streams now, if you look at, so if we go to Keenan Can Do, and you look at the stream that I just did, I'm going back now, be going back in time with them, and I've actually added some chapters. So just kind of cool things that I thought. I listen to it usually the next day, and then some of the cool things that I think that might be of a benefit, I went in there and I added chapters for everybody. So I hope you like that. I hope you like the stream. If you do like it and you want to continue to get more streams like this, don't hesitate to hit that bell icon, subscribe, and thank you for learning C programming along with me. Until next time, bye-bye.